again, the idea is to make sure all of us are on the same board. And when it comes to understanding that what's an impact or what's the role of a design in different phases of a process, and how your design is impacted by what process model you're using. We'll not be looking at this again and again, but I'll just try to come here and say, remember the very first one, which was like, very basic approach or simple process where basically you take a problem statement. Let me start the recording if you're interested. Oh, someone has started. Thank you very much. So basically what we do is we have a simple problem statement and we just start coding it. And there's no, as such, if you notice, there is no explicit design phase here. While on the other hand, if we jump to maybe waterfall model, you have what you call the complete requirements, and then you go to a complete design. While on the other hand, if you're using a continuous integration approach, basically you're taking a part of your requirements and then you're doing a design of it, and then you take another set of requirements and you do a design, and you keep doing this and you keep designing your application, evolving them, and eventually you can have a system. While another multiple release or incremental model, as we discussed on Sunday, or more like an agile model, basically again, you take a requirement and you do design of that part, and you keep doing this, and then you keep designing and evolving your system, and you keep releasing your applications back and forth, right? Now, is this clear to everyone? Anybody has a question? This is where we stopped the other day, right? So anybody has a question on this before we move on?
I think it's
Yes.
clear.
Doctor, what do you mean by design? Design what?
Yeah, absolutely, it's a good question. Now, we'll talk about this today, inshallah, right after once we finish this, maybe a couple of slides. But since we're just going to discuss it, by design, we mean the structure of the application, of the software application, and all the low-level details like class diagrams, functions, methods, what kind of variables it will pass between different methods, all of that. This everything is design, right? And the reason we have been, I have been showing you different process models is because I want you to understand that the thing you do within a design phase is not going to change much. But what exactly you do in that will depend on your input, right? And this input actually is based on the process model you're using. So if you're using a waterfall process model, your input will be complete requirements, right? While if you're using a multiple release or a incremental model like an agile model, your requirements, not the old requirements are there in for your design. Maybe only a small set is used as an input in this case. Then another small set is used for the second input. Of course, this comes in here as well. So you keep evolving it and you keep changing it. Eventually, all the requirements have been incorporated into design. Is this clear?
Yes.
Okay. So moving on, do you recall what's the spiral model? Anybody recalls that from your 205 days?
The risk management, I think.
Absolutely, absolutely. Now, if you look more closely, since because this is a design course, see, because of the nature of the process of the model itself, there is a design phase, definitely. But at what stage it's done, how it's done, it's actually driven by the process model itself, right? So this is different from incremental, which is different from, for example, waterfall, right? So today's message, as was the message on Sunday, is that yes, design will happen, and it will happen at any software application you're developing. But what you really do in a design it will depend on your process model, and that will be driving it. In certain cases like waterfall process model, you will have complete requirements since you are expected to develop a complete set of design in one go, while in case of incremental, probably you not for, probably for sure you will have smaller set of requirements to start, and then you will design it, and then you will take another set of requirements and you design it, and so on and so forth. Similarly, for example, if you look at your RFQ or rational unified process, again, the design is there. So it's always integral part of the software development. But the level of detail, like in this case, level of detail becomes increases in a certain phase, and then it kind of stabilizes, right? Because you have done changes here and it has gone through enough changes, and then now it's very stable. Cool. So uh, I think there's only one or two slides which was remaining that day. Now, my question to you guys is, are you clear why I was showing you the process model, why I started with reviewing the process model? What is my intention?
To show that we have different options. We have different designs, so we choose what's more usable with our situation.
Yep, yep, absolutely. Anybody else would like to comment?
Yes.
Go ahead, please.
The design depends on the type of process, depends on the inputs and outputs of the process.
Yes, absolutely. As Yahya said in the chat, to show us that design may have different inputs. Absolutely, yes, yes. So this is the idea that, when someone gonna say design, yes, I'll be doing architectural models, I'll be doing class diagrams, all of that stuff. But whether I will do it all in one go, whether I'll do it in smaller increments, all of this actually is driven through your process model. All right, and this is why I start with process models and a very quick overview of process models, just to make sure that as we move along, and we're going to talk about design in a lot of details throughout the semester, this bigger picture should always be there in our mind, right? Okay, so with this, alhamdulillah, very important and fundamental understanding, let's move on to another important, related topic. Are you able to see this one now?
Yes.
Yes.
Okay, perfect, perfect. So now, since I have given you a bit of an overview, I'm going to now give you a bit of overview of the design principle, as well as one of our colleague or student just asked me, what exactly is design, right? When I'm saying word design, what exactly I mean? So inshallah, now I'm going to try and explain what I really mean by design, right? Still very high level. We're not going to really talk about a lot of concepts, and we're not going to talk about a lot of nitty-gritty details here, but still it will give you a bigger picture of when I'm saying design, or tomorrow you're going to say a word design, what exactly what we mean by design here. Now, this lecture, inshallah, we'll talk about the importance of design, and then we'll also look at, what is the difference between architectural and detailed design, because they are two very important parts of a design, or together they help to make you a design of a software application. And we'll look at structure versus OO as well. Probably not today. We'll see if we have time. And also the structural aspect of functional decomposition and relational database design as well. Probably not today, but inshallah on Thursday. But regardless, you were not able to hear me, right?
Yeah. Now we
I
hear you.
Yeah, I just realized. Which part where you stopped hearing me?
A minute ago, I think.
A minute ago. Okay, so let me say it again. I just realized the message popped on my screen. Now everybody can hear me?
Yes.
Okay,
Yes.
perfect, perfect, perfect. So as part of this lecture, we're going to talk about, the importance of the design and what is different between architecture and detailed design. Now, this for sure, inshallah, we'll talk about Thursday. But since we're talking about here, I just want to raise the point here that this word design is used in multiple ways, okay, and it has different meanings, even in the software development industry. So I'm pretty sure either you guys have taken the database course or you guys are taking the database course now, correct?
No,
Yes.
it's closed. It's closed, doctor.
It's closed.
Yes, I wanted, but I can't.
May Allah make it easy for you. But overall, either most of you guys are either registering or have registered the 3 to 4, or have taken it. So they will also talk about database design. Okay, that how you can design your database applications. Uh, yes, we use databases, and databases will be a very important component of our application, and it will be a lot of it will make a lot of important input to our design, especially the architectural design. But when we talk about software design, we're not really talking about database design, okay? So this is an important concept. I want you guys to be very clear about it. I'll inshallah touch a bit more on this on Thursday as well, okay? But let's focus on this part now. So once the requirements, let's read this statement together, please. Once the requirements of a project are understood, transformation of requirements into design begins. What do you think? What do I mean by this statement?
You should have a complete set of requirements before you begin.
Now, if I say I'm not using waterfall, I'm using increment, what will happen then?
It means that you have to understand the requirements before you design them.
Yes, yes. So this means there got to be some requirements documented somewhere. Now, will I take the requirements and design the whole system? Or small parts?
If you are using incremental, you have to design that part of the system.
Yes, and if I'm using waterfall, then I'll design everything. And if I'm using agile, that's a different ball game, right? I'll talk about the agile as we move along as well. Okay. So I think, alhamdulillah, I think we all are on the same page on this. Okay. So what I'm saying here is that once the requirements are understood, basically you're starting your design activity. Whether you do the whole design or you do a part of it is driven by your process you're using for your development. Now, of course, this is a challenging process. When I say challenge, is difficult in a sense because we are using something which is intangible, something we cannot see, the requirements, the documentation, into another set of intangible like design, right? So it's not like civil engineering where you basically, you can go to physically to the site and you say that the building is developed and now the first floor is constructed, the second floor is constructed. And even you can have a 3D model of your building nowadays, even, right? In our case, we have requirements which are written in natural language, right, like English or Arabic. We have some models. Then when we come to design, we'll also have some models, but it's not like physical thing, isn't it? So this makes a bit of challenge. But having said that, as software engineers, we have overcome this challenge very successfully, because nowadays, basically, software is an integral part of life every day, right? Isn't it? It's a crucial part, and we have so much success in developing significant complex applications that yes, there is a challenge, but we're able to overcome this challenge. Do you agree with me on this statement?
Yes.
Yeah, absolutely.
Absolutely. So software design is all about how the software is going to be structured. So this is what we're going to learn in this course, right? How I'm going to structure my application. This is exactly the same as civil engineering, right? When they say, I'm going to make a building, then they decide about the structure of the building, right? And they say, okay, there will be like, so many pillars, right? And this will be the strength of this pillar. And then the walls will be this thick and so on and so forth, right? So similarly, as part of our design activity, we design and decide what will be the structure of the application. And how we do it, basically we say, what are the components of this system, right? This is the first thing we do. And the second one is how these components are related to each other. So a design is something about structuring of the application, and how we do it, basically we say, what are my components? And once I know my components, I need to also understand how these components are related or interacting or talking to each other. Is
Doctor,
this point clear? Yes, please go ahead, please.
a component. What could be a component of a software?
Good question. Good question. Anybody would like to comment on it before I answer it? What is a component we
Yes.
talk about? Yeah, go ahead,
Yes.
please.
For example, classes, functions, right?
Absolutely, absolutely. Anything else?
I think objects. Anything.
Objects.
Yeah.
Objects, yeah. Okay.
I mean,
Yes.
outside of coding, do we have any other components?
External components?
I don't know, maybe something like, I don't know, not objects, not packages. Is it all about the coding? Is there anything else?
Anything else? Okay, good. I'll comment on all of these points. Absolutely. And anybody would like to also add something before I comment on it?
Maybe the requirement or the design document isn't that a document a component of the software?
Interesting observation, Yasir. Anybody else before I comment on it? What's the component?
Maybe users.
Maybe users, yeah. Okay. Now, let's look at the component as something which is going to help make my application, right? Now, at the moment, we're using the word component in a very high level, and I'll talk about this word component in clear probably in week 4 or 5, okay? But today, just to help us understand and visualize what I mean by component is eventually is going to be a piece of code, okay? Eventually. Now, this piece of code could be written by me, or it's already prepared and I'm just using it, okay? And my application at the end of the day, as software application, as we always start in 205, a software consists of code and its documentation, right? So code is a fundamental part of our system. So we have a source code. A component is something which is doing a certain functionality. Okay. Now, at a very high level, we may say a component is a user interface, for example, right? At the end of the day, this user interface is a code, right? Isn't it?
That's true.
Or a group of APIs and function calls and so on and so forth, right? Maybe we have written this code completely by ourselves, and in some case or most of the cases, we have inbuilt APIs and we just use those APIs to make those user interfaces, right? But those APIs at the end of the day are also software code, right? So as software application at the end of the day consists of code, and these components are actually collection of these codes. Some of this is written by us, some of this is third party, or we use the APIs to develop it. And it could be user interface, it could be business logic, right? It could be database, it could be, even in some cases, these user interface are interacting with certain hardware, right? So these are our components. Our application design is actually all about what are my components and whether these components interact with each other directly, or maybe they talk to each other in another way, so and so forth. Is this clear?
Yes.
Yes.
Yes,
No.
kinda.
Yeah, and it's okay if it's absolutely not clear. It's okay because I'm gonna make this very explicit definition of this word component in maybe 2-3 weeks time. But today, for the time being, uh, understand that when we talk about design, we are talking about structure of an application. And when you say structure of application, this means I will have components, and components are, a collection of source code. Now, what this is, what level it is it object, as some of us said, or is it class, or is it, a package, right? Just bear with me for a minute, and I'm gonna dig into it now. Okay. So, for a large system, usually we divide this what are my components and how these components are related to each other, this part, right? uh, so this part, what are my components and how they are related to each other for a large application. And when I mean large, I mean anything which is not 1 or 2 assignment. Okay, so we divide them into something called architectural design phases and detailed design phases. Now again, from your 205 days, do you recall any architectural design style?
Event driven, something like that. Maybe.
Repository design, maybe.
MVC, maybe.
Yes, MVC,
Layered.
layered, and so on and so forth, right? A client server. Now, this at the end of the day is what? These are my components, okay? And so server and a clients, and then we have something called detailed design, which is actually you take each one of them and you dig into it and you come up with something like, class diagrams and functions and, uh, interaction between these function design patterns, all of that stuff. Okay, is this clear?
Yes.
Okay. Now,
Yes.
of course, we will be spending a lot of energy and time during this semester, maybe first 2-3 weeks on this part, and a lot of time on detailed design as well. But for today, I want you to be able to understand that when we talk about design, we are talking about architectural design and detailed design. What is an architectural design? Architectural design is a high-level overview of the system. Okay. So when we say component at an architecture level, we're talking about overview, high-level packages, components. Okay. And they are basically they are the components which tells you that my system consists of, for example, user interface, and it has a database, and it has a set of business logic in it, right? And you also look at the relationships among them. For example, user interface can only talk to business logic, and business logic can only talk to database, and the data can only come back and forth this way, right? So architectural design gives you an overall high level overview of your system. It's not talking about, for example, in this level, we are not talking about classes. We are not talking about objects. We're not even talking about functions. Is this clear?
Yeah.
Yes.
Yes.
Okay, absolutely good. Now, let me erase this one. This is an important point. Have a quick read of what I'm saying here. The functional and non-functional requirements, along with some constraints, provide most of the drive for architecture. Okay. In other words, your functional requirements and non-functional requirements, or what I usually call them quality requirements, are the most important input for you to decide what is the most suitable architecture for my application, right? Going back to our civil engineering examples, I have 10 different kind of bridges I can construct, right? I can have a hanging bridge. I can have pillars, right? And so on and so forth. So based on my requirements, based on my constraints, I decide for a software application what will be a most suitable architecture of my application, right? An architecture of application will tell me what are my components and what's the relationship between them. Okay. Now, why non-functional? Why non-functional? Functional, okay, you say, I know, yeah, functional makes sense. Why non-functional? It has got anything to do with the architectural design?
Doctor.
Yes, please.
For example, if one of my quality requirements was security.
Yes.
This will affect my architecture so that I will have to limit the access to my database.
Absolutely. Absolutely. So hence the way you're going to structure it, right?
Yes.
The way you're going to structure your components will be different, right? And you might say, no, I will not never allow this connection, right?
Yes.
So yes, absolutely. So functional requirements, of course, are always there, but non-functional requirements actually play even a more significant role when it comes to architectural decisions. And this is your design decision, right? So on the other hand, the detailed design, actually, you take these components, the ones you selected here, right? So you take them and you basically go on and decompose them into smaller, finer units. So this is more to do with like classes, okay, or objects or functions. Now, are you able to visualize this with me now?
Yes.
Well, there was a question maybe in the beginning of the lecture, and we said, oh, what's a design, right? So now I'm sure you guys are on board with me saying, okay, when I'm saying design, it means I'm talking about architecture of the application, and I'm talking about what are the components, and then I'm also talking about within a component what it looks like it has a class, one class, 5 classes, functions, so on and so forth, right?
Yes.
And
So
this
it's
is
like
design. Yes, go ahead, please.
it's
Yes,
like the structure.
it is the structure, absolutely, absolutely. And of course the detail is like, building architectures, right? So you have one diagram which is showing you the overall look and feel of the building, but then you will have so many other details in it as well, right? We do the same
Right.
thing. We look at an application, we look at its functional and non-functional requirements, and we say, okay, for this application, this is probably a most suitable architecture, and then we'll take those components and decompose those components into classes and functions, and actually at the end of the day, everything is a source code. Now I'm saying here something very interesting here. For detailed design, I'm saying the architecture and functional requirements drive this phase. What happened to non-functional? Because for architecture, I said, architecture is impacted by functional and non-functional. Now for detail, I'm saying it's driven by your architecture and functional requirements. So what happened to my non-functional?
The architecture is driven by the non-functional, so we can say that detailed design is driven by the functional and non-functional requirements.
Yeah, indirectly, right? Inherently.
Indirectly, yeah.
Yes,
Inherently.
yes, inherently, yes. So the architecture provides general guidelines, and overall, all the functions have to be addressed by at least one module in the detailed design. Let me show you a diagram, and hopefully this will become more clear. Let's see what is happening here. Because I cannot see you guys. Everybody is comfortable with this? Everybody is on board with me here?
Yes.
Yeah.
Yes.
Yeah.
Yeah, doctor.
Okay, perfect. So let's see what is happening here. You have requirements and you have architecture and detailed design, right? So this together, sorry, what happened here? Okay, so what's happening here is that you have this together is your design, okay? And your complete requirements R1, R2, R3, by the way, you know, they are your functional requirements, and of course you have some non-functional requirements here as well. Together they drive your architectural decision, right? So you don't really look at one by one each requirement and say, okay, for requirement that I should have an authentication, this is an architecture. No, you look in total overall picture and you decide for this system, this is a suitable architecture, okay? And then this architectural decision you have taken plus all the requirements, these functional requirements, are then detailed, are shown or modeled in a detailed design. Of course, detailed design is more like class diagram, right? So your detailed design is influenced by both requirements plus your architecture. Now let's read this statement now. Does it make sense now?
Yeah, now it's a lot clear.
Right, so what I'm saying, for architecture gives you guidelines and all functional requirements have to be addressed by at least one module. This means if I have R4, for example, here, right? And this R4 is a functional requirement, okay? And I don't have anything here. What this means then?
There is a problem.
Not functional?
If it is a functional, for example, and it's not here.
It's not complete.
It's not complete, right? So there is something missing in our design. Of course, this and of course, does it have to be only one-to-one mapping?
I don't
No,
think
I don't
so.
think.
No, it doesn't.
Yeah, it's not a necessary thing, because here we're saying at least that we want to make sure that all of them have been considered in our detailed design, but it's not necessary one-to-one mapping. It can be all over the place, right? So you can have, it could be done in 5 different classes, right? Of course, we'll always try to have structure which is easy to do and coupling and cohesion, and we'll talk about this later, inshallah, as we move along the semester. But for the time being, for today, it's good enough to know that, you know, they need to be captured. Most influential requirements may be non-functional requirements such as performance and maintainability, right? As you guys also said in the beginning, right? Your architectural decisions, which eventually will drive your detailed design, most of the time actually are influenced by your non-functional, or sometimes I call them quality requirements, right? As you guys said, maybe security is very critical. Hence, you will structure the application or you will select an architectural style which is suitable for it. And hence, your detailed design will reflect it. Correct?
Yep, that's absolutely right.
Absolutely. Yeah. Inshallah, as we move along, I'll show you, I show you more examples, of course, right? I think we already discussed this, so let's look at this. Ideally, there is one-to-one mapping between each functional requirement and module in a detailed design, right? This is a very good, it will be an easy design, right? It will be a design which is easy to maintain if you have only one-to-one mapping, right? One requirement, one piece of detailed design module, right? Which could be, you know, a class or whatever, and it's, or a package, and it's actually doing that work. Usually it not necessarily it happens this way, right? It's a very ideal world. If in an ideal world this will happen. Architecture drives the detailed design. We just had a look at this, with the mapping being ideally from one architectural component to several detailed components, right? So in other words, ideally we like to have each requirement has its own module, right? And then one of these layer of components will be, you know, captured by different modules of your application. Okay. Okay, now we come to very interesting questions now. Let me ask you this question before we talk about this. When you guys, what was your project in your ICS 102 course?
Sudoku game.
Pseudo game.
Pseudo game, right? Now,
Yeah.
when you guys were doing that pseudo game in 102, at that time, did you think about an architecture?
No, only coding.
Only coding, right? Which is absolutely right. Now remember the process I showed you on Sunday and today as well, which is the simple process, right? The most simplest process, right? In which you
Yes.
basically take a problem statement and start coding it, right?
Yes.
There was no as such a design there, right? It was not like a phase as such, right? Now let's read this statement. As you guys said, when you guys developing that game in ICS 102, you didn't explicitly come up with an architecture, right? You didn't document that. But do you reckon you had an architecture or you had some design? Though you never draw anything, you never put it on a piece of paper, maybe you were not even aware of this concept, right? But you now, if you look back, you think you had some architecture, some structure, some components.
Yeah, it's like an
I think
early
yes.
plan.
Yes, Yasser, I lost it, please.
A plan.
A plan, right?
Yeah, simple structure.
Simple structure. Did it has user interface, even a command-based user interface?
Yeah, it has.
It
I
has,
think,
right?
yeah, very simple. No?
And there was some logic.
Yeah, was.
There was a logic, right? So there was some structure. Maybe it was a very simple two-layered one, for example, right? That you take an input from the user interface and pass it on your logic, get the results, and show it back to the user, right?
Right.
Right. So sometimes for small applications, and of course, what I mean by small applications is like applications which are like one or two examples in a sense. You don't have explicit architectures, but you still have architecture. Okay. Maybe we don't know it, right? But in a more traditional software processes, especially like a waterfall process or a incremental process, you do what? You first of all create design, right? And then you refine that design and add more details into it, correct? And then at the end of the day, in a very ideal world, the programmers basically are only supposed to do what? The mainly job is to translate that design into an actual code. All right. Now, this is a very ideal situation, correct?
Yep.
That I design something, I come up with an architecture of an application, which means basically I'll come up with the structure of my system. Then each structure of the system, I'll go on and create, for example, class diagram for that, right? And this will also have its own class diagram. Imagine with me, they are packages, right? And I have done this. Now the programmer will come, he will take this and he will translate it into a source code. To be honest, based on my industrial experience over the years, this rarely happens, right? That you are able to 100% translate this into a source code in one go. There are many reasons for that. One reason is sometimes we don't have enough programming skills to do that to begin with, right? As a developer, right? And there could be many other reasons.
Yes, Doctor, I have a question.
Go ahead, please.
You know KVPM delivery, right?
Yes.
Do we consider it as small system and we don't need to make architecture for it?
Good question. No, I don't know how they developed it, but probably they developed it using Agile, right?
Yeah, it may be
probably. Now, This will lead me to the question I had in my mind. Okay, for a ideal traditional software development processes like waterfall or date or incremental, you will, of course, you will come up with, an architectural design, and you will come up with a class diagram, and then you will try to code it, right?
Yes.
It's a very straightforward game. But what if I'm using agile? What will happen in that case? Do we have design in an agile?
Maybe we use pattern.
Maybe we use patterns, yes.
Yeah, I
But
think there is design, but
there is
it has a different way to do it than other processes, as we talked about.
exactly. There is a design, right? But the way we document it, the way we model, maybe, especially the documentation part is different. It's not very explicit. It's not very detailed, right? And it evolves over the time, but there is a design, okay? Especially there is an architecture for sure. So even if this KPM delivery, if they developed it using agile, probably they will not have, a lot of sequence diagrams. Probably they will not have a lot of activity diagrams, but for sure they have an architecture to the application, right? It's probably a client server, and for sure they have some diagram of their functions or modules, right?
Yes, but I don't think it's a really big system. I mean, only one
From a size
programmer maybe
perspective.
can do.
Yeah, the size. Oh, okay. From a size perspective.
Yes.
Yeah. From a size perspective, yes. No,
Yes,
basically they
so
have a
it's small.
database. Yeah. They have a database. They have a user interface, and you know, of course, they have connections with the restaurants, and so they have logic definitely.
Yes.
So, is this clear, right? What I'm trying to say here?
Yes.
Okay. Now, how much time we have? Oh, 5-7 minutes. Okay, that's fine.
5 minutes.
Okay, so probably I'll not go into this one, but let me clarify a few things here now. Okay, so is this clear to everyone? Like, let me go back. Is everybody on board with me that what is a design? When we'll say design means I'm going to have architecture, I'm going to have detailed design. Okay, they go hand in hand. And the second thing is when you are designing your applications in a very traditional way, you will come up with a design document and then you will do the coding. In an agile process, you will go the other way around usually. You will go on and actually do the coding first, and as you move along and you document your designs and you evolve it. Can I be confident here that you understand that your designs are there is a question by Turkey. I'll talk about this very shortly. First, my question to you guys first is, are you able to now visualize with me that your design is impacted by your process?
Yeah.
No, it's clear.
Good, alhamdulillah. And regardless of which process you're using, you will still have architecture and you will still have detailed design, okay? Now, the question comes because in a traditional approaches, I think everything is clear. I'll take requirements, even a waterfall model, I'll take a normal requirements, I'll come up with a complete design of it, which means I'll come up with an architecture. I will come with a detailed design in terms of classes, functions, everything. And so is true for incremental. Now, the question which Turkey is putting is, can you talk about design in agile? Now, what happens in an agile? And by the way, before I even answer this, agile is something which is used heavily in the industry nowadays. For example, maybe a couple of years ago when I was visiting Sweden and I visited one of the companies, they were developing software applications for risk management of banks, right? So we're talking about some significant, large, critical application here. and the whole application was being developed using agile approach. All right. So what they really do in agile, they have user stories, correct?
Right.
Right. So they have some
Yes.
requirements. So for sure they have some requirements. Now they believe, so let's say they're using, sprints. So they go on, take those user stories, start coding with it, correct? Now when they start coding with it, they don't just randomly start coding with it. For sure, they have something in their mind about the structure of their application, right? And this decision, this what's my structure, what's my architecture, is taken not by someone who's less experienced. It's usually taken by someone who has significant experience of software development, right? So let's say someone who has developed a lot of mobile applications, it will become very natural for him that looking at the user stories, he can tell that, for example, this application needs to be client server application, right? So they take decisions about architecture for sure. Now, they don't come up with a very large, significantly large software design documents in which they detail and go to nth degree of sequence diagrams and talk about, what each object will do and so on and so forth. But they still have design, and that design is actually done in a reverse way where basically they'll do the coding first, right? And then whatever is happening and they are refactoring their design, their code, they come up with the structure of your application, and this structure of the application keeps evolving. Okay, are you able to visualize this with me now, that
Yes.
what happens in an agile? And agile is real, something very popular in the industry. Okay,
Can I have a question, Doctor?
Yes, Saud.
Sorry for interrupting, but
Go ahead, please.
We can say that agile is the structure of it update every cycle.
Yes.
Yeah.
Yes, correct.
Okay, thank you.
You're absolutely correct. Now, the key point here is that they design or document things which is absolutely required. This is what their philosophy is. So probably, sometimes they will not have sequence diagram. They will say, no, I don't need sequence diagram for everything. Maybe they will have sequence diagram as part of their discussion for some critical parts, right? But they do have design. That design is slightly different documented. For sure, they have architecture. Absolutely. Like even in your ICS 1 or 2 example, very small system, we realize that there is an architecture. Whether it's explicitly documented or not is a different ball game. So is true for agile. Larger systems, they do have an architecture and they do document it in one shape or another. Okay. So I think we can stop it here. Let me take the attendance online, and think we can stop it here, and we can, we'll continue with this. Only few slides to go with this, with functional decomposition. Inshallah, I show you these guys that how we can do this functional decomposition, and what's its role. And then inshallah on Thursday, when I finish this half of the lecture, which is very small part remaining, we will continue with inshallah ta'ala the key part, which is your object-oriented designs. Okay, so it's 10:50 here. If you have a question, feel free to contact and ask me now. I will be available inshallah during the office hour as well. I'll be available on Microsoft Teams. If you have a question, you can just message me, and then you can call me as well. And inshallah, all the best, inshallah, and I'll see you on Thursday.
Thank you, Doctor.
All the best,
Thank you.
Thank you.